Welcome to this tutorial on arithmetic sequences and equations of lines. Look at this first problem on the board. We want to do two things. We want to determine a recursive formula and we want to determine a direct formula for the sequence. First, we notice that between each pair of numbers in this list, the terms decrease by 11. When you have that constant rate of change in the sequence, it's called an arithmetic sequence. It's a special sequence. And it's basically a line, y equals mx plus b, where that number, the rate of change, is the slope. So how we work with this sequence is straightforward. In the direct formula, we think about y equals mx plus b. Now, we did a shortcut in class. To determine the b, we went back to the previous term. That would involve adding 11 here, and it would give us 26. That will be the b. It's the y-intercept. It's the value of the sequence when n equals 0. So we could just simply write our direct formula now as a sub n is equal to our slope, which is negative 11, times n plus b. And the b was 2026. That would be our direct formula. The other way you could come up with that rule is take the slope, which we know the slope is negative 11, take a point in the list, and here, for example, we know the first item in the list is 2015. And then we would plug into y equals mx plus b. So the y is 2015, the m is negative 11, x is 1. We would have to add 11 to both sides, and we would get that the b is 2026. In Algebra 1, for the equation of a line, here's what we would have written. Y equals negative 11x plus 2026. For the direct rule in here, though, we change the y to an a sub n, and we change the x to an n. You likely looked at things similar to this in geometry. The new part for what we're doing here in Algebra 2 is we're looking at what's called a recursive formula. And all that means is we're defining the sequence in relation to the previous term. There's two components I always need to see. The first would be saying that a sub n plus 1 is equal to the previous term, which is a sub n, and then in this case what we do is we subtract 11. And you also need to specify the first term in the list, and in this case the first term in the list is 2015. In tandem, those two items form our recursive formula. Now that we have investigated this first approach to arithmetic sequences, here's the second type of problem we consider. The first thing that we want to do is do a little translation. Instead of having these items of a sequence listed, we're going to write them as ordered pairs, where the subscript is the x value and the actual number is the y value. Now, in order to calculate the equation of the line, because remember an arithmetic sequence is y equals mx plus b, we need to start off by calculating the slope. Remember, slope is y2 minus y1 all over x2 minus x1. We'll consider the second point to be the point on the right in this problem. So y2 is a negative 518, subtract y1, which is the 112, divided by x2, now make sure it comes with that same second point, minus x1. I always stress to please calculate the numerator and the denominator separately. That way you don't make any mistakes. So we're doing negative 518 minus 112, which is a negative 630. In the denominator, we're doing 55 minus 20, which is 35. And polishing that off, negative 630 divided by 35 is negative 18. So at this stage of the game, we know our slope is negative 18, and we take either point. I like to choose the point that avoids negatives, less likely to make a mistake that way. And we will plug in to y equals mx plus b. So here it'd be 112 is equal to a negative 18 times 20 plus b. So 112 is a negative 360 plus b. And when we take 112 and add 360, we get 472. So back in Algebra 1, we would have written y equals negative 18x plus 472. In here, for Algebra 2, when dealing with sequences, we'll write it as a sub n is equal to a negative 18n plus 472. That's our first answer, and that would be the direct rule. Please label it, but there's more to this problem. We've got the direct rule. Let's use it to calculate the 400th term. So A400, please show me the plug-in. It's negative 18 times 400 plus 472. Type it in my calculator. And I get negative 6728. We're still not done though, because we also need to figure out the recursive rule for this sequence. In order to do that, it's pretty straightforward. So over here I'm just going to write recursive. The recursive rule always has two parts. First, to find the n plus first term, we take the previous term, which is a sub n, and in this case our slope is negative 18. So between each pair of terms, we subtract 18. The other component is we need to specify the first term in the sequence. Again, we'll refer back to the direct rule, and we'll plug in 1 for n. So in this case, it would be a negative 18 times 1 plus 472, which is just going to be 472 minus 18. So the first term is 454. Please make sure that on a test or quiz or any other assignment that you would clearly label the direct rule, the recursive rule, make sure you have both parts of the recursive rule, and answer any other question that might be posed. That would take care of this problem, and this is an overview of arithmetic sequences, which are basically the equations of lines.